Hello everybody, I hope you're doing well and welcome to the platform of CodeChef. So today we'll be solving the problem Chef and Numbers. The difficulty level for this problem is Cakewalk and there are no plugins required whatsoever to solve this particular problem. This is your educator Ansh and I hope you like my video. Now let's move on to the problem statement. Okay, now let's try to understand this problem statement. So basically let me just summarize the entire problem statement for you. So firstly, what is the Armstrong number? So question has told us Armstrong number can be defined as the following. So basically, consider any number. Say my number is 153. So firstly, I have to count the number of digits in this number. So as you know, there are 3 digits in my number. So currently, let me just name my P as 3, which denotes the number of digits. So in my 153, there are 3 digits. Now, for this particular number, it is my Armstrong number if my individual digits, so say 1 is my individual, so 1 raised to P plus my second digit, which is 5 raised to P plus 3 raised to P, and here P is 3. So my case becomes 1 raised to 3 plus 5 raised to 3 plus 3 raised to 3. And if the whatever value of this particular expression comes, so when you calculate the value of this expression, it comes out to be 1 plus 5 cube is 125 plus 3 cube is 27, right? So 1 plus 125 is 126 and 126 plus 27 is 153. So this entire expression turns out to be 153. And as you can see, my 153 is same as the original number. So for any particular number, if my this calculation turns out to be the original number, it is my Armstrong number. So the question is asking that only, that I have to print feels good if my given number is an Armstrong number, and I have to print feels bad if my given number is not an Armstrong number. So yeah, let's move on to the approach for this particular problem statement. Okay, so now in order to approach this particular problem, what I can do is firstly, when I have my number n, my first thing is to count the number of digits in this number. So firstly, I'll take my n and I'll count the number of digits in my number. So let's denote it by p. So this number of digits can be easily counted by just taking n as a string and obtaining the length of that string, right? So now I obtained my number of digits p. So now what I can do is I can traverse in my n, I can traverse in that string, and for each particular number, so I can traverse in my n. So for I in n, that is my n string. Firstly, let me just typecast this into an integer. So let my int a be like typecasting this string to an integer, and then what I can do is I have no value of p. Initially, I can initialize my answer as 0, and then I can add the value of answer plus is equals to, since for the Armstrong number we have to do I raised to p, for the entire number I can just simply add I raised to p, which is nothing but of I comma p for the each and every character in my number, and then finally whatever my answer turns out to be, if it equals to n, then it is my Armstrong number and I'll print feels good. Otherwise, if this condition fails, then in my else condition I can simply print feels bad because it is not an Armstrong number, and this becomes the approach for solving this problem. Now let's see how we can code this particular approach. Okay, now let's try to understand the code for this particular problem. Firstly, we include all the header files required. Then, for t-test cases, we input the n according to the input format. Now what we do is, we initialize my current number as n, which is nothing but a temporary number. So we'll use this particular number as a temporary variable to traverse across the digits. Then we initialize our p that was discussed in the approach section as the number of digits in this particular number, right? So while my number is greater than 0, I divide my number by 10, and this way I can just extract all my digits from the number. So I can, if my number is 1 to 3, then the count of that will be 3, and my p will get incremented 3 times, and hence I'll get my p as a required length of number, or the number of digits, right? Number of digits in that particular number. Then I again initialize my number as n because my number got 0 while traversing this particular loop. And then what we do is we just extract the remainder for the following thing using number divided by 10. So we extract digits from the number, and then for the following digits we just raise it to the power of p. So that was the definition of our Armstrong number. For each and every individual digit, We have to raise it with the particular power as the number of digits in that particular number. And then if my answer turns out to be n, I simply write feels good, otherwise I write feels bad. Okay, now let us run our code to the sample test cases to check whether everything is working correctly. So as you can see, we got the correct answer required for this particular sample test cases. Now let us submit our code and see whether the code is working properly for the actual test cases. So as you can see, we got the correct answer for the following problem, and yes, this becomes a valid solution. Let me show you the Python implementation as well. So in Python implementation, I am doing the same thing. Just I am calculating p as directly by typecasting the required string into my string, typecasting the required integer into my string and calculating the length for it, and then I apply the same loop of calculating the remainder and raising it to the power of p, and then I add it to my sum, right? And this iteration over, I'll have my final number, and if my final number is equal to the initial number that is given in the question, then I'll feel good because it's an Armstrong number, otherwise I'll print I feels bad. Yeah, this becomes the approach for this problem. Also, now where could people go wrong in this particular problem? So I think if the approach is clear and the observation clear, I don't think there's any logical or syntactical error that people can make in this type of problem. So yeah, I hope you like my video. Please like, share and subscribe to our channel. Thank you.